All right, I'm gonna record it. Yeah, so welcome to the first mechanical team meeting. Um, so essentially, we're going to be meeting at this time every single week now at 4 p.m. on Saturdays to kind of discuss what we need to do and any updates that we have so far. But for this week, what I'll be mainly going over is the sub team tasks that I'll be giving you guys. So I know I've kind of put people into teams, or you guys already chose your sub teams. But for any new people who haven't chosen yet, it's okay. You can wait till the end to choose. But yeah, so I'll be just kind of mainly going over each task. And I have a small update slide at the end. Um, yeah, so, okay, so starting with the camera stabilization slash mount team. So your task for today is to create a CAD model of the camera mount um, and have a prototype ready by next meeting. So you have a week to work on that. Um, so this mount has to be adjustable, meaning that it can move up and down the T slot. And it has to be detachable just in case we need to detach it for whatever reason. And you can create multiple iterations based on your type of vibrational damper. So I know that Jose, you have like different types of dampers that you want to test out, right? Is that right?
What do you mean? I already tested them out. Yeah.
Oh, okay. Um, well,
I just
since
want to show everyone else.
okay, so since you guys have already worked on it since last semester, do you guys already have a CAD model ready, or you guys are still working on it?
Um, I don't know what Nelson and Joseph have so far, but I've been working on a different task, and I just been leaving it up to them.
Okay.
Oh, that's Jose.
Damn, Ariel, where have you been?
Okay, that's
Oh,
What's
fine.
up, Marianne?
Um,
what's up, guys?
what's up, video? Welcome. Haven't seen you in a while.
Is Tim in
Yeah, I haven't seen him. Yeah, Tim's in here.
Hey, yo, Tim.
Uh, who's this? Richard?
Hey, yo, Tim.
What's up?
Did you see the parts finished printing already from Brian? Check your phone. I sent them to you.
Okay, cool. Thanks for the update.
Yeah.
Okay. Sorry about that. So moving on. So I want you guys to have that done by next meeting. And then in terms of testing, you guys have your vibrometer and accelerometer ready. Uh, is that correct? I'm not sure. Like, you guys have it
Jovan
ready to
said
test?
Jovan said he did have the accelerometer done right with there when he was talking about it. The
Uh-huh.
vibrometer, he said he's confident on it, but he's gonna keep working on it just to be sure.
Okay. Well, he already knows that we're gonna meet together next week to kind of test it on the
Damn,
chassis. So,
is that
uh,
is that 100%, bro?
I want to say like
That's what you said about
90%.
this Saturday, and look where we're at.
Okay, that's 90%. But yeah, so that's your guys' task. So for each team, let me know any questions after the meeting. So I don't want to have to drag on the meeting for too long. So moving on. So the acrylic covering slash waterproofing team. So I kind of added that waterproofing since last time we met. So your guys' task is to create sketches um, that are kind of based on acrylic that will cover the entire robot. And I I would say it can be done by next meeting. I don't think it's anything too difficult. So you guys will be having six 24-inch by 24-inch acrylic sheets that you are able to work with, and I'll be kind of like helping each team out on their task as well. So if you look at the bottom right, so that kind of drawing mimics the acrylic, the kind of like the laser cut outline of what I want. So these cuts represent the brackets on the chassis and also the bolts that are gonna hold it onto the chassis as well. So you when you make these sheets, you have to keep in mind that we want to maximize the area of what we're using, and we don't want to have any leftover sheets, if that makes sense. But if it doesn't, I'll be going over that with your team. And then the second task is look for ways to cover any gaps. So the T-slots naturally have gaps in them, and we kind of have to find a way to cover it because we need to make it waterproof. So you can design some end caps, or we can put wax, but we can discuss that as a team later. Okay, so moving on to the acrylic electronics box. So for this team, your guys' task is to make a box that can be assembled with our screws that we have. So those dimensions are going to be on McMaster, and I can send you guys the link to that later. So I kind of want to have this done by the 20th. So that's going to give you guys 2 weeks to work on that. And then same thing from the acrylic covering team. So you'll be having 6 24-inch by 24-inch acrylic sheets. And if you look at the bottom right picture, so you guys will have that entire space to work with, because I'm not sure if the EE team wants to kind of cover that entire area, if it's easier for them, but I would have to talk to them about that, and this team as well. So there's that, and then you guys will be working alongside the EE team to determine the electronic spacing between the components. So we can either lay it flat or stack them. We'll see which one's easier because we don't want to make things too difficult. I think we should think it in terms of ease of taking the electronics apart. Because when it comes to repairing, or if anything shorts, we have to replace it quickly during the competition. So that's something to think about. And then in terms of the actual wiring itself, you can actually do it on SolidWorks. It's called SolidWorks routing, and you can wire, I guess you can wire components from the box to the battery, for example, to see where the wires are going to be placed. So you can practice on that for now. I guess this task isn't urgent, but it's kind of good to see where the wires are going to be going. So there's that. And then, so moving on to the static load simulation team. So I think for right now, we should start with the 2D free body diagram of the chassis. So I'm really unsure about this thing because it just seems so difficult to do right now since we kind of lack resources to kind of learn about it. But I'm still trying to do research and see what we can do. So
Wait, SolidWorks gives shear and moment body diagram? What?
no, we're so that's gonna be created by hand.
Oh, okay.
Yeah, so let's see if we can create a shear moment diagram by next meeting. And I was thinking maybe we can use method of sections since we have a lot of sections. And that's something I need to look at again. So that's kind of up in the air right now. And then you guys can actually create the chassis on SolidWorks Weldment. So that's different from the chassis that you guys seen so far in the pictures. So weldment just means that everything is welded together instead of bracketed. So that makes it easier for the analysis portion on SolidWorks. So you guys can do that and place the distributed loads from the battery and the payload. So those two things are the most, they weigh the most. So the battery weighs 32.6 pounds and the payload weighs 20 pounds. So let's see how far we can get with that. But I do want you guys to continue, I guess, doing research and I guess start on the weldment. Okay, moving on to the next team, bolt preload. So I want you guys to create a MATLAB code to determine how much torque is needed on each bolt. So we actually have two different types of bolts, one from McMaster and one from T-Nuts. They both use different finishes and actually are different materials. So the one from T-Nuts is cheaper. It's not as strong and the finish is like pretty crappy. Yeah, because I pulled it out of my garage right now and the nuts are already rusted. So it's not really like waterproof or anything or weatherproof. But so just keep that in mind. We're gonna have two different materials and finishes and stuff like that. So the way you would calculate it, it's based off of its finish, the type of material, the threads per inch, etc. I think I'll be helping you guys in determining all that. So yeah, just keep that in mind. And then I want you to look into SolidWorks simulation for the torque on the bracket and T-slot. So essentially, I want to see how the torque affects the brackets and the T-slot using the torque that we found from the MATLAB code, if that makes sense. Yeah, that's pretty much it for this team. Oh, and the due date, there's no due date for that right now, since there's a lot of research required. So I think each week, if you guys don't have a due date, I kind of want updates every week. And just a small update slides. So I'm going to meet up with each sub team 1 to 2 times throughout the week to help you guys in your tasks and kind of explain what to do and I guess how to do things. So this is kind of dependent on your guys' free time. So you guys can determine when your guys' free time is today and let me know so that I can meet with each team, maybe for, I guess, half an hour to an hour, depending on what we're doing. I guess the time doesn't really matter. I just want to meet with you guys throughout the week to kind of help you guys. So things regarding the laser cut. So the laser cut deadline is the first week of March, and that's when we're going to actually laser cut things. So that's why for most of the acrylic teams, I have due dates for you guys. So just keep that in mind. And then the next bullet point is testing will be done sporadically and will not be mandatory to join. So in terms of testing, it's mostly just the custom brackets that are 3D printed and maybe like testing out sensors and stuff like that. In terms of the ME team. Yeah, I think that's pretty much it for today. Does anyone have any questions? It was kind of a lot, sorry.
For that bolt information, you're gonna send us that, right? Or you're gonna just post it on the, like, for both the acrylic, the ones that you say you have for the acrylic electronics box, so there's specific bolts that we have to fit.
Oh yeah. So
Yeah.
for that, so going back to this slide, it's going to be similar to this team. You know how you create cutouts? So the cutout sizes are determined by the bolt sizes. So I'll be giving you information on that. Yeah, I'll be giving you any information that you need. So don't worry about that.
Okay.
Yeah. All right. Any other questions? So I was kind of thinking, maybe not today, because I was actually thinking of meeting each team after this meeting, but I just realized like not everyone can join us today. So yeah, so please let me know when all your team members can meet, or at the very least most, so I can help you guys on your tasks and kind of help guide you guys, and then give you tips or anything, or stuff like that. So does everyone have a sub team?
I'm good here, Tim.
Yes, sir.
Yeah.
Yeah, because I noticed there was a couple more people joining the ME team. So if they're not here today, and if you know them, please update them on what we're doing. Yeah, I think that should be it for today. Pretty short meeting. So to kind of give you guys an idea, next week I'll be having a slide from each team on their progress, and I guess we're going to discuss like future tasks and any updates. And yeah, I mean, if there's no other questions, I guess meeting adjourned. This meeting was pretty straightforward, so yeah. Okay, so I guess I'll catch you guys later throughout the week. So just please send me that schedule as soon as you can, and then we'll meet up.
For sure.
Sound good?
Yup.
For sure. Sounds good.
Thanks, bro. I
Alright.
appreciate it.
All right, cool.
Thanks,
That's good.
Tim.
Yeah,
Later,
no problem.
guys. Have a good week.
See you
Alright, you
Tuesday,
too.
Gio.
Right there.
All right,
See you
have a good week.
on Thursday, Joseph.
Tuesday. Oh wait.
No,
never
no,
mind.
Thursday. Huh?
Yeah.
Yeah. Late.
All right, see you.